Hello, so in this video I'm going to discuss section 2.4 from the book, okay, which is the chain rule. So far we saw the power rule, we saw the derivative of the sum and difference of a function, we saw the product rule, right, we saw the quotient rule, we saw so many rules, okay. But they are able to do so many problems involving the derivative of a function. But there are some more functions that we don't know how to find out the derivative, okay? Let us take an example. So if y equals to x plus 1 whole squared, that is square, how do you find out y prime? Okay, for this one, it was not a bad problem because you can write this as, let's say y equals to, you just FOIL it, right? You can do x plus 1 times x plus 1. So before you find out the derivative, you just simplify it. So if you FOIL this, x times x is x squared plus x times 1 is x plus 1 times x is x plus 1 times 1 is 1. So you get x squared plus 2x plus 1. That's what you get, right? Now, when you find out the derivative, you write y prime equals to, find out the derivative of x squared is how much? 2x, right? And then what is the derivative of 2x is plus 2 times derivative of x is 1, right? Because I'm using this formula. And then plus the derivative of 1 is 0. So your final answer is basically 2x plus 2. That is the derivative. Now, you see what formula did we use here? We used derivative of x to the n with respect to x. That's what how we call, right? The derivative of x to the n with respect to x. Meaning that if you match this base x, that x, with that x, but the numerator x has some exponent, then you write the exponent times x to the exponent minus 1. Okay? If both of them matches, xx or tt or yy, uu, like that, if they match, then you can use that formula. If they do not match, you cannot use that formula. For example, on this case, look at this case, x plus 1 squared. If you want to find out, let me write slightly different way, okay? Suppose you are writing this derivative as d over dx plus 1 to the square over dx. Look at this. You cannot use that formula directly. Why can't you use that formula directly? Because look at this. That has, it is like x to the n, you can think that way, but that x is x plus 1, right? There is x plus 1 on the base. There is just x in the base. If they don't match, you cannot write like 2 and then x plus 1 times 2 minus 1. You cannot write that way. That's not how it works. You need to have the same just x and just x there. Or just u and just u. Just you need to have the same variable here and here to use that formula. Okay, so I was able to use that because this the derivative of x squared is basically dx squared over dx, and you could write 2x 2 minus 1, and then you're writing 2x, right? Similarly for this one, you're writing 2 and then dx over dx, right? You can write dx to the 1 and then 1x 1 minus 1, or you can cancel that and say, you can think that way, okay? You can think the cancelling of those, and then you can say just 1. So 2 times 1 plus the derivative of 1 is 0. So you can think that way. But this problem was not very bad because you were able to FOIL it, okay? And then write that form. But if I take y equals to root x plus 1, then how do I find out y prime? Because I cannot FOIL it, right? You cannot write like, you can write this as x plus 1 to the 1/2. That is what the root means. But I don't know how to do after that, what to do after this, right? So if I want to find out the derivative, do you know that this derivative can be written as dy over dx is same as y prime? These are just the different notation, but the same thing, right? If you want to find out the derivative of this, then how would you write that is dy over dx. I'm finding with respect to x because x is the only variable here. And then you write d over dx x plus 1 to the 1/2, right? Now look at this. You cannot use just simply the power rule here. Why? Why can't you use the power rule? Because there is x plus 1, right? There is x plus 1 in the base. There is just x in the base. So they don't match. So you cannot use the power rule. So how do I do this type of problem? So the method or the rule or the formula to do this type of problem that has exponent and then cannot be simplified is called the chain rule. Okay, it is called the chain rule. So it is very, very easy. Don't panic. Okay, so how do I do this type of problem is I will do this way. Okay, I will write let u equals to x plus 1. I will write this as x plus 1. Then how can you write that then? Then I will be able to write this as, I'll be able to write like dy over dx as I will be able to write du to the 1/2 over dx. Now it looks better, but still a problem because we didn't do anything new. I just denoted that base, not with the exponent, just the base as u to the 1/2. Okay. Now I want to use the power rule. My goal is to use the power rule because there is power, right? But I cannot use power rule 8. Why? Because there is u. You see that? There is x. They do not match. But how can I make them match is I will do like this. Du to the 1/2 over du times du over dx. You see that? You can think of like cancelling du and du, right? But what you get is ultimately you get du to the 1/2 over dx, right? If you cancel them out. But you don't want to cancel because you want to use the power rule for this. Because see, now they match, right? There is u to the 1/2 divided by u. Now they match. You see that? Now, look at this. So what is the derivative of that? You use the power rule 1/2 u 1/2 minus 1 times. What is the derivative of u? Look at this. Derivative of u with respect to x, okay? You will find out the derivative of x and 1 separately. Derivative of x is 1, derivative of 1 is 0. So that is just 1 plus 0. Okay, now, how can you write that? So it is 1/2 u to the negative 1/2. You see that? Because 1/2 minus 1, this is 1 plus 0 is just 1, and then you multiply with 1, it stays the same, right? Now, how do you do that? You move that to the denominator because I don't like the negative exponent to keep negative exponent. So I want to move that 1 over 2 u to the 1/2. Okay, now you can write this as 1 over 2 root u. But here is the problem. Your question was in terms of x. Your answer must be in terms of x. So you need to replace that u back. So the final answer here is 1 over 2 root under x plus 1. That is the derivative of this function. Okay, so that is the derivative. But here this was like I was trying to make them match. I was assuming that as x plus 1, just the base, not the exponent. I was assuming that as x plus 1, that as u, right? And then you were able to write this is u to the n. If you do that, you were able to write u to the n, right? And when you find out the derivative, you're trying to find out the derivative of u to the n, right? So derivative of u to the n. So what did we do? The derivative of u to the n was, it was like we were using on this part, we were using from here to here, we were using n times u to the n minus 1 times, and that part is basically u prime, right? Times u prime. That's what I was using. So that is the now updated power rule. Look at this. These are the formula, right? Du to the n over dx. Look at that. They don't match here, right? There is u, there is x. If they don't match, then this is the formula you use. Okay, what we did is we made them matching. You did du to the n over du times du over dx. If you cancel that, you will basically get that thing. So you divide it and multiply by du. You can think that way. Okay, so what is the formula there? The first one has formula because you can use the power rule here. U to the n and then u. So they match here. Now, so you can use the power rule. When they match, you can use the power rule n u to the n minus 1 times, this is basically u prime, the derivative of u with respect to x. So what you can think here is, look at this. If the base do not match, if that u do not match with that one, then what we do is you use the power rule here. Basically, you use the power rule times the extra thing that you do is u prime times the u prime. Don't forget that. Okay, that will be times the u prime is the extra thing we will need, because you remember that if you have dxn over dx, See, they match. If they match, then you can do nx n minus 1 because they match. These two bases match. Okay, but if they don't match, then what we do? Du to the n over dx. They don't match here, right? You see that? There is u, there is x. In this case, what you do is you still use nu n minus 1. Why don't they have x? Because the base was x here. That's why I wrote the base. Here the base was u. That's why I wrote the base. Times the extra thing you need is u prime. That is the extra thing you need. Okay. So if they do not match, if that value is different from x, then we have to multiply when you find the derivative, we have to multiply the extra u prime. Okay, that is the main thing on the chain rule. Okay, so let us see some other formula there. So what are the other formula there? Okay, let us see the second formula. D sine u over du. Okay, look at that. What is the formula for d sine x? D sine x over dx. Look at that. Here they match, right? Here this x and x match. So in that case, the formula was cosine of x. You see that? But here they don't match. There is u, there is x. So what is the formula then? The formula is you try to make them match. D sine u over du. You are making them match, but this is the extra thing. So I multiplied by du, and then over dx is that same dx. Now this one, they match, right? That u and u match. So you can write cosine u, that is the derivative of sine u, times du over dx. That is the extra thing. That is times u prime is the extra thing. Did you understand that? Okay. So therefore, if you have d sine u over dx, then that will be cosine of u, because the derivative of sine u is cosine u, times, because they don't match, I multiply by the extra u prime. You understand that? So if they don't match, if the variable on the top and the bottom don't match, then what we do is we try to make them match. And you don't have to show this middle term here, middle step here. Okay, you can just write the first equals to the last. So the derivative of sine is cosine u, okay, times, since they don't match, we need to do u prime. Look at that cosine u. What is the derivative of cosine u? Is negative sine u, but since there is u, that prime is the derivative with respect to x. Think that way, okay? This prime is with respect to x. This assumes that there is dx in the denominator, okay? So since there is u, not x, then we write negative sine u is the derivative of cosine u times u prime. So can you think of the derivative of tangent u? What is the derivative of tangent x? That is secant square x. So tangent u will have secant square u times, since there is u, there is no x. If it was x, the formula will be secant square x only. Since there is u, you write u prime. You understand? Now let's look at the secant u. So what is the derivative of secant u? Secant u is secant u times tangent u times, since there is no x, there is just u, we are finding the derivative with respect to x. That prime represents with respect to x or with respect to t, whatever, okay? Since there is u, then you do times u prime, okay? Similarly for cosecant, it is minus cosecant u, let me write c as c, cosecant u times cotangent u times u prime, and cotangent u is negative cosecant square u times the u prime. Okay, so this is how this is nothing new. Okay, we have the formula of all these trig ratios already, and we have the formula for this. Only the difference is if that base or that angle is different from x and you are finding with respect to x. If that angle is u, but you are finding with respect to x, then you need to multiply by, you write the same formula as before, and you need to multiply by u prime. That is the new thing we are doing, okay? Let us see this example. We have y equals to 5 times 1 minus 2x to the 4th. Okay, so I don't want to FOIL that 1 minus 2x to the 4th. I want to use the chain rule, okay? So find y prime. So how do I do this? What I want to do here is I want to set u equals to 1 minus 2x, not with the exponent, just the base, okay? Set u equals to 1 minus 2x to just 1 minus 2x. Then you can write y equals to how much? 5u to the fourth. Okay, now I want to find out the derivative. So it is like 5 times u to the fourth, right? Since this is just 5, you can pull that out. So what is y prime? Y prime is 5 times the derivative of u to the fourth, right? It is like u to the fourth prime. So you can pull that 5 out. This is just a constant, so you can pull that out. Now we need to find out the derivative of u to the 4 prime. This prime stands for derivative with respect to x, because that is x there, right? Now how do I do that? Is 5 times, use the power rule. It is 4 times u times 4 minus 1 times u prime. That is the extra thing we will need, because we have u there, we don't have x there. That is the reason. Okay, so how much is that? That is basically 20 u to the 3 times, what is u prime? You find out the derivative of that, right? If said u equals to 1 minus 2x, then what will be u prime? You need to find out u prime equals derivative of 1 is 0 minus derivative of negative 2x is negative 2 u, and then derivative of negative 2x is negative 2 times derivative of x is 1, right? So that will be negative 2. That's what you get, right? So times negative, I'm sorry, let me write that form, times negative 2, times negative 2. Now, but your question was in terms of x, so you want to write your final answer in terms of x. So 20 times negative 2 is negative 40 times u is 1 minus 2x to the 3, u to the third. That is the final answer. Okay, so it was a lot easier. This chain rule made the problem very easy. Okay guys, so we will do many examples so that you will be used to with this chain rule. Let me list all the formulas so far. That's a chain rule formula basically. We are assuming that u has x in it, right? Because we assume that u equals to some x or t, whatever. But that prime is with respect to x or t, but there is u to the n. So the formula is n times u to the n minus 1 times u prime. For derivative of sine u is cosine u times u prime. Cosine u is negative sine u times u prime. Tangent u, the derivative is secant square u times u prime. The derivative of secant u is secant u times tangent u times u prime. Cosecant u, derivative is negative cosecant u times cotangent u times u prime. And finally cotangent u, the derivative is negative cosecant square u times u prime. Okay, these are the formula, updated formula, where we use this is the chain rule formula basically, right? So let us do some examples here. Let ft equals to negative 2 times 10t square, okay, 10t cubed plus 3 root under, and find out f prime of t. So what do you assume for u? So basically ft is how much? So you can write f of t is equals to negative 2, and then you can write 10t to the cubed plus 3 to the 1/2. You can write that way, right? It is like u to the n. You can write u to the n. So what we do is let u equals to 10t cubed plus 3 without the exponent. Okay, so now what will be f prime of t then? F prime of t equals to, so basically you can write ft is basically negative 2 times u to the 1/2, right? That will be ft. So when you do you can write here too. So let u is that much, then ft will be negative 2 u to the 1/2. Now you need to find out the derivative of this with respect to t, not with respect to u. That's why you need to do n minus 1 times u prime, right? So what is f prime of t then? That will be negative 2 times n, that is u to the n, right? U n minus 1 times u prime. You see that? So that 2 divided by 2, that you can cancel out those two 2's, that one and that will cancel out. So what is left is negative 1 times u to the negative 1/2 times. What is the derivative of u with respect to t? Because the t is the variable here. The u prime is 10 So basically 10 times the derivative of t cubed is 3t 3 minus 1 is square plus 0, right? Because the derivative of 3 is 0. That is u prime. So basically you can write this as negative 1 to the u to the 1 half, right? Because you move that to the denominator because it has the negative exponent, times that is 30t square plus 0 is just 30t square. Now I want to write that u in terms of t, right? The replace back the value of u, okay? So how much is that? That is negative 30 t square times 1 is 30t square times negative 1 is negative 30t square. Divided by that can be written as root u, right? What is under the root though? What is u? It is 10t cubed plus 3. That is the final answer. Okay, so this chain rule is basically the highest level of formula in the derivative. Okay, so if you know the chain rule and all the product and quotient rule, then you pretty much know all the rules of the derivative. There is some more like implicit differentiation in the next section, but the formula, these are the formula that all we have. Okay, next is, let us look at this example. There is plus in the middle. Okay, cosine has, if there was cosine x only, then the derivative will be negative sine x, but there is x squared plus 1, so you need to take that as u and you find out the derivative. Similarly, there is 3 times x minus 2 square. Okay, so that will be another u, so you will have to treat them separately there. That is separate u's. Okay, let's do that. So you have, let us set that as u. You can take that as v and then just find out the derivative of v. That is perfectly fine. Or you can take u1 u2 that way. Okay, so you have g of x equals to, basically you have cosine of u plus 3v squared, like that, right? You see that? Now you need to find out the derivative with respect to x though. With respect to x, what is g prime of x? That will be, what is the derivative of cosine of u? Cosine of u will be negative sine u. That is what it is, right? Negative sine u times u prime, right? Plus 3 times, what is the derivative of v? It is like v to the n, right? V to the n is n v n minus 1. If there was u, that will be n u n minus. You can assume that as u, that is perfectly fine, but that u and that u will have the different value. That's why I was assuming that as v, just give you the different notation. Okay, so 2v 2 minus 1 is just 1, right? Times v prime. So let us not write this 1 because 1 is considered there. If there is nothing, there is always 1. Now let us plug in back. So negative sine u times, what is u prime? U is x squared plus 1. Find the derivative of x squared plus 1 is 2x plus 0, just 2x, right? 2x plus 6v times, what is v prime? V prime is derivative of x minus 2. X minus 2 is, derivative of x is 1 and minus derivative of 2 is 0. So 1 minus 0 is just 1. That is 1. Now we plug in back the value of u and v. Negative sine x squared plus 1 times 2x plus 6 times v is x minus 2. So we assume without the exponent. If there is just one exponent, we assume without the exponent. We will see more complicated form later. Okay, but for now, just u or v is considered the base value. Okay, so next example, that's the final answer. Okay, you can write the 2x in the front, so you can write like negative 2x times sine x squared plus 1 plus 6x minus 2 or 6x minus 12. That is the final value for g prime of x. Okay, let us do this example. There is a product rule. You need to use the product rule. Okay, it is like u, don't get confused with u and v. Let me write down this line like f and this like g. Okay, f and then g. So what is the product rule first? So the product rule is f prime times g plus f times g prime. You see that? That is the product rule. So you need to be careful on that first. So let us write down the derivative, and then within that product rule, we will have to use the chain rule. Okay. So what is h prime then? H prime of x is equals to f prime is x plus 1 square prime This is f prime. This f is the whole thing. Okay, when we use the chain rule, that chain rule will assume that inside thing is u. That inside thing will be like a v or u again. Okay, but since this is the product rule, the whole thing will be f. The another whole thing will be the g. So f prime times g sine x minus 5 to the third. This is f prime times g plus f is x plus 1 squared times g prime is sine x minus 5 cubed prime there. This prime stands for derivative. Okay, now you don't have to do anything for this term and that term, this term and that term. You don't worry about that. We'll keep that in the final answer. But this one has a derivative. So you see, on the derivative, I don't want to FOIL this. I want to assume that u and v there. So just take that as u, and here there is also derivative. Just take that thing as v. Okay. So how do I write that then? So that will be basically I would write, it is like n, this is u to the n, right? U to the n prime. It is like 2 u 2 minus 1 times u prime, and just write that as it is, times sine x minus 5 to the third plus, and then x minus 1 to the square. That chain rule is only for the derivative. If there is no derivative, if you are not finding the derivative of that term, you don't need to use the chain rule. So we need to find the derivative of that term. So again, that has n is 3. It is like v to the 3, right? N v, and then n minus 1 is 3 minus 1 is 2 times v prime. What is the v prime? Let me write v prime for now, and I will find out the v prime later. Okay, so what is 2? 2 is there, 2. U to the 2 minus 1 is 1, right? So u, what is u prime? U is x plus 1, right? So the derivative of x plus 1 is 1 plus 0 is just 1 times, there is sine x minus 5 to the third plus x minus 1 times 3v squared times, what is b prime? V is sine x minus 5. Okay, so v is sine x minus 5. So sine x, derivative of sine x is cosine of x minus 0. That is the v prime. Okay, now let us write the final answer, but we want to write in terms of x. We will replace back u and v. Okay, so that will be 2 u is x plus 1, and then times sine x minus 5 to the third, and then plus x minus 1. Okay, let me write down 3 on the front. What is v? V square, right? That is sine x minus 5 squared times the cosine x. Okay, so you can live like this, or if you want to be nicer, then it is 2x plus 1. Okay, let me correct something. This is not x minus 1, this is x plus 1, right? You see that? This is x plus 1, this is x plus 1, x plus 1. Now I want to take x plus 1 out. Okay, so because x plus 1 is common to all of those, right? So there is, by the way, there is square as well. There is x plus 1 is square, x plus 1 is square. So I want to take x plus 1 out. What is left is 2 sine x minus 5 to the third plus, there is x plus 1, one of the x plus 1 is taken out, right? That will be 3 cosine of x times x plus 1. This is separate, okay? This cosine x is separate, x plus 1 is separate. And then because I put that cosine x out, you could write 3x plus 1, 3 times x plus 1 times cosine of x. I think that is better way to write. Okay, let me do that. So 3, and then write down x plus 1 because one of the x plus 1 is taken out, and then write down cosine of x, and then inside the parenthesis there is sine x minus 5 to the square. That is the final answer. Okay guys, so basically the idea is same, but since this is the highest level of the formula we use in the derivative, so it is a little long. We'll have to use all the power rule, product rule, quotient rule, and then chain rule in the same problem. Okay, so these are a little bit complicated type, but once you do a few examples, then you will be perfectly fine. You will like it. Okay, let us do this problem. If y equals to 2x over x squared plus 4 under the root, then find y prime. So let us take this as like f over g. Do you remember the formula for f over g? I wrote that like u over v, right? Still you can find, but I just wanted to not confuse you. For we assume that as u as well later, and then there are many u, I mean same u for different things. I don't like that. That's why I just want to do f and g there. Okay, so what is the formula for the derivative of f over g? It is f prime times g minus f times g prime over g squared. That is the formula, right? Let me use that. So what is y prime? So the y prime here is basically, so the y prime is equals to f prime is 2, the derivative of 2x is 2, times g is root x squared plus 4 minus f is 2x times g prime is root x squared plus 4 prime. You see that? Over g square is root x squared plus 4 and then square of this. You see that? Now the first term we will keep as it is because there is no derivative there. So that will be 2 root under x squared plus 4. Alright? Minus 2x. What is the derivative of that? So let me show you how to find out the derivative of that, the root x squared plus 4. Okay? So there is x squared plus 4 to the 1/2, and you are finding the derivative of that prime. It is like you can think this as like this, the inside the parenthesis is u, so it is like u to the 1/2, right? Basically what you have is basically u to the 1/2, that is basically u to the 1/2 and then prime, right? What is the formula for that? You use formula number 1 there. That will be 1/2 and then u and then 1/2 minus 1 times the u prime, right? So 1/2 and then u to the negative 1/2 times, what is u prime? U is x squared plus 4. So that will be just 2x. You see that? So you divide that 2 with that 2, that cancel out. So what you get is x is in the top. I want to move this to the bottom. Root u, right? So what is the value of u though? X over root under x squared plus 4. That's what I'm going to write there. So 2x times x over root under x squared plus 4. That's what you get. You can leave like this, or the better way is you just make the same denominator, okay? Because there is 1 in the denominator, you multiply the denominator and write that thing. So by the way, I forgot the overall denominator is x squared plus 4. Okay, so again, as I mentioned, you can just leave it like this, but your online homework is a little picky about how do you write the answers. Okay, so you better simplify this one. Let me simplify those things since I'm running out of space there. So what I want to do is I want to simplify that here. Okay, let me write the same denominator on the fraction in the numerator. So what you do is on the numerator you can write root under x squared plus 4, because 1 times root under x squared plus 4 is root under x squared plus 4. Now you do the conjugate multiplication like that. Okay, so what do you get? 2 times root under x squared plus 4 times root under x squared plus 4 will be just x squared plus 4. That's what you get. Okay, minus 1 times 2x times x is 2x squared, whole divided by x squared plus 4, right? And then there is always 1 in the denominator of that, so I want to write like this. Let me FOIL the numerator first. 2x squared plus 8 minus 2x squared over root under x squared plus 4, right, times 1 over x squared plus 4, like that. Now you can cancel this negative 2x squared and positive 2x squared. This is just the algebra concept, right? So just simplifying. So what you get is 8 over, there is x squared plus 4 to the 1 half. There is x squared plus 4 to the 1, right? That is just exponent 1. It is like multiplying. Do you know how do you multiply x to the 1 half times x? You just write the same base and then write 1 half plus 1, right? It is basically x to the 3 half. That's how you combine those two. So similarly, how you do that, there is x squared plus 4 to the 1 half is for that, and since you are multiplying with that, plus 1. So your final answer for this problem, that example is 8 over x squared plus 4 to the 3 half. This is the form of answer the website like, okay? So basically that will be 8 over x squared plus 4 to the 3 half. That is the final answer for this problem. Okay, so let me do another example here. We will do many examples as I mentioned earlier. So let me do this problem here. Okay, there is a chain outside, the whole power is 2, and then there is quotient inside. Okay, so how do I handle this problem? So what I'm going to do here is I want to assume that this whole thing as u, so it is like u square. Okay, so basically you have f of x equals to u square, right, where u is t square, or f of t, I'm sorry, this will be f of t because this is function of t. On the right hand side, t is the only variable. Okay, f of t. So f of t equals to u square, where u is t square over t to the 4 plus 1. So what is f prime of t then? F prime of t is equals to 2u to the 2 minus 1, that is just 1, right, times u prime. So what is u prime? That can be written as 2u times u prime is t square over t to the 4 plus 1, that is u prime. I want to find the derivative of that. So that can be written as 2u times, what is the derivative? You can think that as like f over z, right? You can think that as f over z. See, what is the quotient rule? F prime of z minus f z prime over z square. Let me do that. Okay, guys. So let me do that thing. So you will basically get f prime is 2t times z is t4 plus 1. F prime times z minus f is t square times g prime is 4t cube plus 0. You see that? Because t to the 4th has 4t, 4 minus 1, 4t cube plus 1 has derivative 0, divide by g square is t to the 4 plus 1 to the square. You see that? Let us simplify that. You will get 2u. How much is that? That is 2t to the 5 plus 2t. Because you see that 2t times t to the 4 is 2t to the 5 plus 2t times 1 is 2t. Minus 4t to the 5. Divide by t to the 4 plus 1 square. Okay, I should have put that the value of u here too, so that it will be one step shorter, right? What is the value of u? You just replace back. So it is t square over t to the 4 plus 1. Now look at this. You have t to the 4 plus 1, t to the 4 plus 1 to the square. So the overall will be, it is t to the 4 plus 1 to the cube, right? 4 plus 1 to the cube. Okay, now you FOIL this, but before that, what I want to do here is 2 times t to the 5 minus 4 times t to the 5. You can subtract that, right? So it will look like this. 2, you can write like t squared out, that is perfectly fine. And twice t minus 2t to the 5. Because these two are the like terms, you see that? This term and that term are the like. They have t to the 5. There is 2t to the 5 minus 4t to the 5 is negative 2t to the 5. Okay, so if you want to, you can take t out as well, so it will look like this. Okay, so it will look like the final answer. You can, I think the website accept like this answer too, but if you want to be more specific, if it doesn't like that answer, I have to factor that t out, so it will look like, oh, also 2 out, 2t out. So if you take 2t out, so that 2 and 2 will be 4t cubed, right? 4t cubed, and then 1 minus t to the 4 divided by t to the 4 plus 1 to the third. That is the very final answer. Okay guys,